Yeah. Okay. Right, so I have to move this way slightly. Okay, this is where we're supposed to be, not cloud native. This is much better. So, welcome again. As Ollie said, well done if you managed to find us today. We unfortunately have had to move locations a bit. This is our sort of normal place that we meet. Occasionally they're booked out, they can't host us, so we have to go to other places as we did last week. Next week we're here though, right, Ollie?
You should be.
Yeah, next week we're here. And as you will have discovered, for this place you need to register on their website as well as on our website, because that's their requirements. And they've got this funny entry code thing now, but there we are.
If you RSVP with us, then you get sent there. We put the link in the email we send you and on the page after you've RSVP'd, so it's not to miss.
But
you can, if you go onto the Skills Match website, you can sign up to the end to send you.
oh, okay.
We do RSVP for both, or we keep track of, or I think just cognomen?
To both.
Both.
Both, yeah. Okay, as Ollie mentioned, this is C++ conference, brand new one going on in Folkestone in Kent. It's run by a friend of ours, a guy named Phil Nash. It's the first time it's happened. It's going to be really good. If you're just starting out C++, maybe it's a bit early to be attending conferences. But if you're here and you've got some C++ experience and you want to learn more, then this would be a really good place to do it. If you're watching online and you already know a fair bit of C++, then check it out. The tickets are available now on that website. There we are. Advertising pitch over. Okay, who wasn't here last week? 3 of you, 4 of you. Ah, welcome. So if you weren't here last week, you didn't miss all that much. But if you want to go and have a look at what we talked about, the slides are available on our GitHub repository. And the talk is, the YouTube stream is saved. So if you go to YouTube and you search for C++ London Uni, you'll be able to find all our videos, and in particular you'll be able to find the most recent one. Well, the most recent one will be right now, but the one from last week. Just to reiterate a few of the things I said last week, these classes are an introduction to C++. And the sort of format I try and do, we have a mixture of talks, me just standing here giving you information. We have some small class exercises, and we have homework. And then, as Ollie mentioned, on Thursday evenings, we have sort of a meet-up, a gathering for people to come together and work on the homework, or any other C++ they want to work on. And the idea behind that is that it's a way for people to practice and to learn together, right? So if you don't know something, perhaps your neighbour does, you can help each other. We have a couple of experts there as well that you can ask if you get into trouble, and that way everybody gets a chance to learn together. We can't turn you into an expert in these sessions. I'm sorry. I said last week that there's this sort of famous idea that it takes 10,000 hours of practice to get really good at something. And at our rate of about 2 hours a week, that's going to take 100 years. So we probably can't do it just in these Tuesday evening sessions. So practicing by yourself, doing the homework exercises, finding other resources to practice your C++ is really important if you want to get really good at it. Right? The aim of these classes is to give you a start to help you go on to learn yourself. So we can't turn you into an expert, but we'll try and give you enough information to get started. Slide about feedback, and apologies to the couple of people who've been here many times and have seen this slide hundreds of times now. We like to hear from you. We like to know what we're doing well, what we're doing not very well. Any questions, anything like that? We have this channel on Slack that we use, so we encourage you to join that. So if you go to that URL and you put in your email address, then it will send you an invitation to come and join our Slack group, the CPP Lang Slack group. And then once you're in there, if you're familiar with Slack, it's all quite easy. You can find this channel, /CPP London Uni, where we all hang out and, you know, discuss really important topics. Okay, so last week, for the three of you who weren't here, we had a first little look at C++, first introduction to C++. We had a look at the Hello World program, because it's basically the law that whenever you start with a programming language, your first program needs to print Hello World. That's just needs to be done. There's no way around it. So we looked at Hello World, and we looked at the slightly funny way that C++ has of printing things out with this type standard cout that you stream things to. So it's a bit different from most other languages where there's just a print function or printf or println or whatever it might be called. In C++, we have this idea of streams. We stream our things to the console. We also look at the notion of type in C++. So C++ is a strongly typed language. The notion of data types is very, very important, absolutely crucial to how the language works. So if you're coming from a language that doesn't have such a strong notion of typing, say JavaScript, for example, then this, takes a little bit of adjustment. Can do. If you're already familiar with this, if you use Java or C# or what have you, then that should already, the way it works in C++ is very simple. And then finally, we looked at declaring and calling functions. So at its core, C++ consists of data and functions that operate on that data. So obviously, being able to write your own functions and being able to call to execute those functions is pretty important. So we had a look at that, and we'll be having another brief revision on that in just a moment. On the menu this week, we're going to look at some of the commonly used types that you'll be using in your sort of early C++ career. So some of the types that are built into the language, and a couple of types that are part of the standard library that are very, very useful, string and vector. Okay, I'll just pause here and let these guys do their bit with the chairs. Thank you. All right, where was I? Yes, so we're going to look at some commonly used types. We're going to look at variable declarations, so how you declare variables in C++. And then we're going to look at the keywords constant, auto, and what they do in respect to variable declarations. So that's on the menu for today. But before we do that, let's have a brief little revision from last week, because it was a week ago, and that's a long time. So we write a function in C++ in this sort of following kind of abstract form. So I said the notion of type is really important. So we start off by writing the function's return type. So every function in C++ either returns 0 or 1 value. So if the function returns a value, we write the type in there. If the function doesn't return anything, we use this special type named void. So if the function returns nothing, we put void in here. Next up is the name of the function. Hopefully, some sort of brief description of what it does. After the function name, we have these round brackets. And in the round brackets, we write the function parameters. That is, the data that the function takes in. And there can be any number of parameters that we like, from 0 to however many you want. It's, for all practical purposes, unlimited. And for each parameter, we write its type. Because again, notion of type is really important in C++, so we write its type. And then we write the name of the parameter. So inside the body of the function, we can use that name to access that data. And technically, the parameter name is optional. But if you don't give it a name, you won't be able to use that data inside your function. So for each parameter, we write these pair of names, the type, and then its name. And we do that for however many parameters our function takes. So for example, we can write a function that takes two variables, both of type int, and returns a new value that's also of type int. And I've given this function a descriptive name. I've called it add. It probably gives you an indication of what it does. So inside here, these pair of curly braces form what's called the body of the function. That is the list of instructions that get executed when you call this function. In this case, there's only one, and it's telling us to return whatever the value of a plus b is. So the two variables that were input to our function, we called them a and b. A plus b calculates whatever the sum is, and then we return this value from our function. Yes. Oh, this again. Sorry, I don't know why Keynote does this. I'm going to complain to Apple about it. It's only when it's on an external screen. I don't know what's going on. So, let's go. I can go back one. No, I can't. So we've got the function name, before the name it's return type, and then in these round brackets we have type, the type of the parameter, and then its name. And then we put curly braces, and we put what the function does. So again, if you've used Java or you've used C# or any of these sort of C-ish languages, this should be pretty familiar, right? This is not surprising. Yeah, no. Okay, well, let's have a quick go just to refresh our memories. I did actually give you this exercise last week. I don't know how many people managed to finish it. This website, onebox.org, is a little a way of writing and compiling C++ programs just without having to have anything installed locally. So if you go to that, there's a little text box. I think it's got a hello world program in there by default. You can just delete that. And I want you to write a function called sayHello, which, well, does as it says there. Let's give you a little bit of practice at using this standard string type that we're going to talk about today. was summary last week. Yeah.
Port revealed. Tried to install the sequence. And failed. I tried to troubleshoot. It's it sort of crashed on the signal install. I was installing things and was trying to look online. Well, the install meshes. Tried to install the files because I installed the serial and it was asking me to install the signal.
I've done a little bit of so I know
Tristan, to
figure it out.
STL.
New introductory, NUW.
It's like standard out.
I've got some new instructions on this
Namespace
site.
will be the namespace for the library, the standard. I think it's the standard library, and it's got string, it's part of standard library. So getting to the namespace, so we need to use the string from the standard library. So we need to say, so if we're using it for one, we need I think that's how it is.
That's a perfect answer. Yeah. Yeah. Yeah, so the STD tells us it's part of the standard library, that is like the library that comes with install like the C++ library. Yeah.
So how would you start a function then? Do you have to use STD as well?
To write a function, you write a function as I've shown in the last slide. So it depends on the type you're going to use. So if one of your types, or in this case your type is going to be this STD string, so you need to write STD colon string to say I want this to take a string as a parameter. That's the one. Awesome.
But then the C lines was having trouble.
Hopefully this won't crash on the switches, which buttons are the switches. Anybody needs any help raising a hand at all?
You can download the C lines and then start 30-day trial.
For those of you who are online, you may also pose your questions in the YouTube chat.
Yes. Yeah. I would suggest you use something to get that.
Oh yeah.
You can say, what do you think of Alexa?
String and suddenly it doesn't work.
Not quite. It is, so main does return the value, but it's returns eventually. So what would usually happen is main will call a function, which calls another function, right? And eventually, so all your execution of your program always starts. Yeah, when main finishes, when main returns, okay, and the return value, so main returns an int, that gets passed back to your so just by convention, your program, if main returns 0, that means my program worked successfully, and if you return something else, that signals to whether it exists.
I think that should be
This is last week. I am going to cover that. That's okay. It was a bit. So last week I had talked about variable declarations, and then homework was you had to use them. So I was being a bit sneaky. I was trying to get things to read ahead. But I will have a look at that just after this. Yeah. Okay. Yes.
this course
It's correct. It's a new string. What happens is you return this new string, you don't do anything. Okay, so you'll create this new string saying hello Adrian. Okay, so what you need to do is print.
Yeah. Well, you can do exactly. You've done it. Does what you expect.
I use the multi-color. In fact.
You're using GCC.
No, see, that's
Oh, that's right. You want
Huh?
and you want to just let one let you do Unicode.
Yeah.
Unicode? Ah,
That's
that's
for everything.
Yeah.
So that's, I think I had that problem as well. Google get line one. You use the type in that one instead of seeing
Okay, how are people getting on with this? Hand up if you're all done. Majority of people, not wrong because he's not concentrating. Okay. So go on. So this is my solution. So at the top, we have to say this include IOStream and include string in these angle brackets. So these are two headers, packages if you like, that come with the standard library. That is the set of functionality that comes bundled with your compiler. IOStream is input and output streaming. That basically lets you print things. And string is this, for this string type in C++ that we're going to talk about shortly. So by including these things, it gives us access to those functions. It gives us access to that functionality. So next up, we have this function definition. So as I said just now, first of all, we write the return type, then the name, and then its parameters in brackets, in these round brackets. So in this case, the return type is this std string. So this means this type string that belongs to this namespace, this collection of functionality. Now, std is a special namespace. It stands for standard. So this is a type called string that belongs to part of this standard functionality. So if we were using another library, then that would you'd probably use the library name in there. So you could have, my fantastic lib, : string, for example. So this is an example of what's called a namespace in C++. It's a way of being able to reuse these short names in different packages, different pieces of collected functionality. So string is a type that belongs to standard. So it's standard : string. So this whole thing is our return type. And then our function is named sayHello, because that's what I told you to name it. And these are our parameters. So we have one parameter. Again, its type is this std string type. And we've named it name. Just does one thing. It says hello plus name. So for strings, the plus operator concatenates the strings, glues them together, and this returns a new string, which is hello plus the name.
And a space.
And a space, hello space. So that's the new bit. Now we look at main. So main is a very special function in C++. Every C++ program has to have a main function, and its return type must be an int. So every C++ program has to have int main. The argument types can change. In this case, we don't need any arguments. So the arguments to main are the bits of information the operating system gives you when you start your program, right? So the command line arguments. In this case, we don't care, so we say that main takes no parameters. But it returns an int. And within this function, what we're doing, we just got one line. We have this, again, standard cout. So this is an object called cout, console output, that again belongs to part of the standard library functionality. So it's got this std prefix. And then we stream the output of our sayHello function to this cout thing. So what we're doing here is we're calling our sayHello function and passing it the argument that we want to call. So what happens is the compiler will look for a function called sayHello, and it will pass it this thing called Tristan. So we jump up here, and name now contains this string Tristan. So it'll execute this, it'll say hello space plus Tristan, it'll create a new string that's the concatenation of those two, so those two glued together. So it'll return a new string that contains hello Tristan. And then the result of this function is streamed to the output. And then after we streamed that, we add another bit, which is, this is just a new line. So as I was saying last week, /n is a shortcut, just puts a new line, literally, in the output. There are a couple of different ways to do it. This is my preferred one. And then that's it. But you might be looking at this and going, well, hang on, main is supposed to return an int. We don't have a return value here. As I said, main is very special in C++. In that for main and only for main, if we don't have a return statement, it automatically returns 0. That is only the case for this very special main function. And returning 0, so the return value from main gets passed back to the operating system. And by convention, returning 0 from your main function means this program executed fine. There were no problems. And any other value indicates an error. And the reason for that comes from the earliest days of Unix, where you could, or you still can, chain together programs and examine the return value of a program to see whether it ran properly. There's a Unix command that you can look to see what the return value of the last program was and things like that. But if you're not really into Unix programming, don't worry. All you need to know is that returning 0 from main means everything was okay. So, who got something like this as a solution? It was sort of half. You're sort of waving your hand in the air. I looked at your solution, it was exactly like this. It was perfect. Okay, so nearly done. Nearly done. So I left you with some homework last week. Well, I didn't leave it with you, actually. I put it on the slides that were put up on the GitHub site. Who managed to have a go at the homework from last week? This is what it was. Quite a few of you, actually. Good. Who managed to get it working? Sorry? Didn't do the vector bit, that's fine.
I got the first one.
Yeah, well, the vector bit was a bonus. Right? That was for people who thought the first two bits were too easy. But we'll briefly go over the solution to this. So, first of all, well, we'll skip the reading about because I'm not sure how I could show you that. But, so we'll write a program which reads in a string using cin, console in, so the input counterpart to cout, and then prints hello, whatever the name was you were given. So my solution looks like this. Again, we have to include this IO stream. That's the standard library's input and output functionality. And we have to include this string type. So what we do is we declare a new variable called name, which has type standard string. Now, if this looks a bit strange and new to you, don't worry, we're going to go over that in this session. So this creates an empty string. And then what we do is we stream, instead of to the output, this time we stream from the input. So we take whatever is on the console and we stream it into our name variable. And then on the next line, we're back to doing output. So we have cout, and then we stream hello, comma, and a space. And then we stream our name that we've just read, so this variable. And then we finish with a new line. So who got something like that? Pretty much everybody who put their hand up for having tried it. So that's awesome, so well done. For the second part, the vector part, this was a bit harder. Had to use some bits and pieces we definitely haven't got to talking about yet. I'll just go through it very briefly. So I've declared a vector, that's like a collection type. And this is what's called a class template, so we have to tell it this is a collection of strings. And I name that names. And then I have this, just a single string, which I call name. And then I want to read, so this instruction in here reads one name from the console, just exactly as we had in the last example. But I've used a trick here that is not really obvious unless you have seen an example that does this. But this expression here, this C in arrow arrow name, this returns a value. And that value can be converted to a Boolean. We can test whether this worked, essentially. So if it returns something that's, as the JavaScript people say, true-ish, true-y, then we'll enter the body of this while loop, and we'll say names, that's this vector, push back, so on the back of our vector, add a new value, and that new value is the name we just read. And because it's a while loop, while just continues doing the same thing until this condition is false. So it'll keep going until it can't read any more strings, until it's run out of inputs. So we keep on pushing all the names into the back of our vector. So once we've run out of input, this returns false, so we jump down here. And now again, I've used another tricky bit of functionality. It's called a range for loop. We will go into exactly what this means. But basically, this prints out every member of our names vector. So this was intended for people who already knew a bit of C++ and wanted to get a bit of a head start.
Why did you use the while loop?
Why? Just because it leads to compact code that fits on a slide, basically.
Okay. And then, like, what was the purpose of you putting a while loop in this piece of code?
Because the instruction was that you had to read a list of names, and you didn't know how long that list was. So you just had to keep reading until you got to, I think I said an empty string, didn't I? Yeah. So what we could have done is just done while true, that would have looped forever. And then if the name we got back was empty, we could have used the break keyword to exit from the loop. That would be another perfectly fine way of doing it. This is just a bit shorter, so the code fits on the slide. But again, this thing of using the return value of this, it's a bit tricky, and I wouldn't expect anybody to just know it. This is the kind of thing you have to have seen, have read in a textbook or on the internet. So this is a solution. There are many possible ways of doing it, yes?
If you wanted to take it from
Just a bit.
to read from the first vector and transfer it to the names vector, how would you adjust your code?
Sorry, if I wanted to...
Transfer the various names
Yeah.
from the first vector or name one to your names.
So how do I copy things from one vector to another?
But since you have various components in your vector,
Okay, so what you're saying is if you have two vectors,
two vectors and you copy each element from one.
so the way you can do it is either just...
with the while. If you would you use some iterator?
You could use iterators. There's an easier way to do it is to use a function called standard copy, or the even easier way to do it is just say vec1 equals vec2, and that will copy everything from vec2 into the first vector. So yeah, this is a kind of a bit of a preview as to where we're going to be going in the next couple of weeks. So if you manage to do that, well done. But let's get on with talking about some new stuff. So C++ has a number of types that are built into the language. They're always available. So this is very common, like Java has lots of, what do they call them? They're called fundamental types in C++. I can't remember what they call them in Java. Primitive types in Java. But in C++ we call them fundamental types. These are the ones that are built into the language. So the names of these types are keywords in the language. So the first one we're going to look at is called char or char, depending on your preference. This represents a single ASCII character. So if you know what Unicode is, this is not Unicode, right? This is very basic. I think it's 127 characters. Basically got lowercase and uppercase English letters, numbers, and some punctuation, and that's it. But this represents a single character. So again, it's not suitable for doing very fancy, you can't write emojis with it, right? But it's suitable for just doing very basic text input and output, as we'll be doing in this class. We also have a type called bool. This represents a Boolean value. So again, many programming languages have a type called bool, Boolean, something like that. Bool can have one of two values. It can either be true or it can be false. And that's it. This sounds very limiting, but it's actually extremely useful for lots of things. Type we've already used and we will be using a lot is int, which is a 32-bit, 4-byte, usually, integer value. An integer maths is a whole number. Right, so 1, 2, 3, minus 27, plus 4,096, whatever it might be.
No decimal place.
No decimal point, no decimal places. Right, an integer is a whole number, positive or negative or 0. 32 bits, that's how specifies how many values we can store, and it's between roughly 2.3 billion and minus 2.3 billion. So if you need to store 2 to the 31 minus 1, if you really want to know. If you need to store larger integer values, there are larger integer types that we'll talk about in a moment. So we have a type float, which is, in the terminology, a single precision floating point number. So again, I've got this little asterisk because, strictly speaking, it doesn't have to be 32 bits. It could be any old size. But every C++ compiler on every system you're likely to use, unless you're using a VAX machine from 1976, any modern system, you're going to get a 32-bit floating point number. So again, if you've done much programming before, this and its companion double, these are very common types in most programming languages. So float and double can store what we call real numbers, that is, numbers that have a fractional part as well. And the difference between float and double, other than double is double the size, is that double can store more precision, that is, more decimal places. And it can also store larger numbers. So when in doubt, use double, basically.